I'm back again with another video on my SAP-1 simple as possible breadboard computer. I built it after watching Ben Eater's videos, inspired me to try to do that myself. This is a follow-up video to the video I posted last night where I was describing the problem I had with the RAM overwrite. I received a reply pretty quickly on that video from Paulo Constantino, and he says essentially that I need to put a pull-up resistor at my RAM's write enable input, so a 1K resistor from 5 volts to the write input. So basically, in looking at the data sheet, and reading his comment, this is what I interpret, that basically I would need a 1K resistor between this pin and the 5 volt rail. And that pretty much coincides with another comment that I received several months back from Stephen Becker. I hadn't actually posted anything about this problem at the time, but I was experiencing the problem. I just hadn't made a video about it. But Stephen Becker commented that he said another issue I had was that my RAM module was triggering a write every time I switched from run to program mode. He says it seems that for some reason the input pin from the manual program push button to the 74LS157 multiplexer was floating low for an instant on the changeover, which instantly wrote whatever was on the 8 bits of the DIP switches to the currently selected memory address. Then he says he put a 10K pull-up resistor on it to prevent this, and it seems to work fine now. So actually the solution was right here in front of me the whole time. I guess I just didn't fully interpret what Stephen Becker was saying back then. And in fact, if you look back at this comment, I replied to him and I asked him a couple questions. And I guess I just never really put it together. But this is basically what I ended up doing as well. So after reading, Paulo's comment, I started chasing down this issue of placing a pull-up resistor, but this specific way of doing it wasn't working for me. And unless I misunderstood what he was saying put the resistor between this pin here, the write enable, and 5 volts. I did that, and I did that actually back when Stephen Becker commented on that post 4 months ago, and that never resolved the problem for me. So I'll show a picture of what I ended up doing. So bear with me one second. So here's a close-up picture that I took a moment ago. So what I ended up doing was placing this resistor using Paulo's suggestion of 1K, or I imagine there's probably a few different values there that would work. I don't actually know how to calculate what value you should use for a pull-up resistor. But nevertheless, Paulo had suggested 1K and Stephen Becker had suggested 10K, so somewhere, I suppose, in that range would work. But rather than putting it on the pin 3 write enable as Paulo was suggesting, I went with I ended up doing what Stephen Becker suggested. I just never realized that this is what he was saying to do. But basically, coming right off the leg of the write button, so this leg goes to ground, and this leg comes out and goes over to the IC. What I noticed after kind of playing around with the multimeter a little bit was when I probed this rail right here, exactly like Stephen Becker had said, he noticed that this was floating when the button wasn't pressed, so it was neither high nor low. It was in my case it was about 1.35 volts if I recall correctly. So yeah, that got me thinking, well, that's not a logical high or a low, so that's definitely a problem. So kind of combining the suggestions of different people and a little bit of my own limited understanding, admittedly, I placed this resistor here on the leg of this button, and yeah, that seemed to have basically instantly solved the problem. I tested it very thoroughly, and I'll add a little bit of video here to the end of this video showing the same steps that I went through last night, and that it's now working as expected. And one thing I wondered was that, did I just miss something when I was looking at Ben Eater's videos? That's always possible. So I went back to this video where he's building this part of the 8-bit breadboard computer RAM module build part 3, posted September 4th, 2016. And I, scrubbed the timeline back and forth here, looking very carefully at this part of the build. And he never places a pull-up resistor. You could put it here between the leg and 5 volts as I've done, or it could have also gone between this pin and 5 volts. Either way would have worked because these are connected electrically. And there may even be some other solution to this whole thing, but this seemed like the most obvious, so this is what I went for. But yeah, I came back to this video and I looked at it very carefully, thinking that, I must have just missed something, but near as I can tell, I haven't missed anything. This is just another case where his breadboard computer is working apparently perfectly without having to do this step that I've had to do. And I've ran into that before. The very first problem that I ever posted was the infamous RC problem that I was having with the program counter, and I ended up just taking that whole thing off my breadboard computer completely because I think it caused more problems than it solved. But at any rate, the issue has been sorted out. I just placed that 1K ohm resistor there like I'm showing, and it's basically just running between the leg of that push button and 5 volts. So with that said, I'm going to fade over into some video now where I'm going to go back over the steps that I went through before. Okay, so I've come in here to my breadboard computer, and I'm just going to put this program that's currently running on pause. It's just the one that just counts by 3, and I'm going to step through the same sequence of steps that I went through last night, where I'm going to program in a binary 1 into address 1 and a binary 2 into address 2 and so on. And the only difference between last night and tonight is that I now have that 1K ohm resistor sitting between the right side leg of this push button and 5 volts. And you can't really see it, of course, on video because that yellow wire is covering it up, but you already saw it in the pictures that I showed. So I'm going to switch over to programming mode, and I'm going to go, like I said, I'll go, that's address 0, so I'll just program in a 0. So address 0, we got a 0. And we'll go to address 1, and we'll program in a 1, and do maybe 1 or 2 more. Go to address 3, then 2, and we'll program in a 2. If I can ever, I have a hard time with these dip switches. So address 2, we plug in, program in a 2, and we'll do 1 more. Address 3, we'll program in a 3. So then the problem that we were seeing last night was if I come out of programming mode, well, first of all, let me cycle back through just to show that the addresses are there. So we'll go to address 0, and we have a 0. We go to address 1, we have a 1. Go to address 2, we have a 2. We go to address 3, we have a 3. So then what I was saying was if I come out of programming mode into run mode, and then I'm going to switch, say, over to address 0, I currently still have that binary 3 on these dip switches, and what would happen before is when I would go into programming mode, sometimes, but not always, whatever was on those dip switches would get written into the RAM, and you can see that did not happen. However, the problem was intermittent, so it's something that I need to test several times. And you could see, and if you saw the video before, you noticed I only had to do it maybe 1 or 2 times usually, so let's test it. So again, I'm not keeping count, but that's many times that I've flipped back and forth between programming mode and run mode, and the binary 3 that's sitting on the dip switches is not spontaneously shoving itself into memory address location 0. So let's go to address 1. At address 1, we still have a 1. And before, just going back and forth in and out of programming mode, I would have whatever was on the, and again, it wasn't necessarily whatever was on the dip switches, because I showed how sometimes the most significant bit and some of the other bits wouldn't necessarily translate over, but nevertheless, more or less, whatever was on the dip switches would go into RAM. And that's not happening here either. So let's try another address. Let's try address, well, that doesn't make sense to try 3 because I have a 3 on there. So let's try address 2. And this time I'll count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I basically switched in and out 10 times, and there was no way I would ever be able to do that before. So I feel like this issue has been completely solved, and I'm very happy for that. So if anybody else runs into this problem, hopefully this putting a pull-up resistor there will take care of your issue as well. Thanks again, and I will see you in the next video, whenever that is.